nice sunset. Hello friends and welcome to Engineering. August 21st, 2017, the day of a total solar eclipse. Just like the bell tower casts a shadow onto the ground, during a solar eclipse, the moon casts a shadow onto the earth. We're going to be using some physics and a little bit of math to understand a little bit about what happens during a solar eclipse. Yo, Scotty, you know this will be the first total solar eclipse in the US since 1979? I think you're gonna need these. Why are we doing this so cheesy? There are my cool glasses. Look like a dweeb with the other ones. So now let's explain some of the science of a solar eclipse. Here's an image of what we're gonna be working with, which is super inaccurate because of the sizes and distances, but it's fine for our calculation. So this is the diagram that we're gonna be using to represent this. Here we have the sun, it's very happy, projecting a shadow from the moon onto the earth. Now only in the special occasion when the projection is completely perfect do we have a total solar eclipse. We can write some equations based on what we know about latitude and longitude. These are the coordinate systems used to describe where something is on the earth. Even though these rings move horizontally, latitude actually describes the vertical position and longitude actually describes the horizontal position. Using what we know about coordinates and physics, we can calculate how fast the speed is moving across the earth. So let's talk about physics in terms of rate. So rate is another word for speed or velocity, and it's defined as rate equals distance divided by time. So if we know the distance of the shadow and the time it takes for it to travel that distance, we can calculate how fast that shadow is going. But see, the rate is actually going to change depending on where it is on the earth. If the shadow moves along the horizontal plane, it will move at one perfect speed. But since it will actually move on a diagonal, we're going to need a function that relates this. According to NASA, a function that predicts the speed of the lunar shadow in kilometers per hour is given by this equation. This V is for velocity and the L is for the longitudinal coordinate. So if we know where we are along the longitudinal coordinate, we can plug this into this equation and solve for exactly how fast we're going in kilometers per hour. Also, according to NASA, there is a formula that predicts the diameter of the lunar shadow in kilometers by this equation. So again, if I plug in any longitudinal coordinate, I can solve for the distance. So now that I have this equation and this equation, I can plug this into here, because remember, rate is still velocity. And now I have two variables and one unknown. So since velocity is distance over time, time will be distance over velocity. And if I plug in these equations, I can solve for how long the eclipse will last. Simply by putting this guy on top and this guy on bottom, I get this equation. Now I'm going to multiply this by 60 minutes per hour so I can get it in terms of minutes instead of hours. Now if I plug this into a graphing calculator or a computer, I can solve for what location will the eclipse last the longest. So you can do this on a graphing calculator by plugging in the numbers. Careful not to do any typos. Make sure the longitude range is from -124 to -79, which is about the longitude range for the US. I also did this in MATLAB, so you can see what I did. I'm just dividing the distance by velocity and plotting it, and I got the same graph in both results. So you can see that the maximum time is about over here, which will be almost 3 minutes. It seems like the max is about, -83, which is in Tennessee. So that means if you live in Tennessee, you'll be seeing the eclipse for about 3 whole minutes. Anyway, I hope you enjoyed this. If you have any questions, please feel free to leave a comment. Check the links in the description, including my website, Engineering, and I'll link the website from NASA to show you the calculations. This just goes to show you that math and physics can be fun sometimes, and you get to learn too. Feel free to subscribe and to share this with any of your friends that might enjoy this.